Okay, thank you very much. I think normally this now would be like a NASA astronaut or like a sports star or something. I'm none of that. I'm not even a mad scientist. I don't have a long beard. I'm just a pretty ordinary person. But thank you very much for kind of staying with me for the next half hour. I think, I mean, at a very kind of meta level of what I heard anyway today, a lot of the questions in the end is, I guess, especially regarding artificial intelligence, but not only that, first of all, to develop the technology isn't so easy, and then to implement it and get it used is even harder. And we heard a little bit about how you need to have a socio-technical approach to look at that, how you need to have to bring the user in, etc. And that's, to me, a question actually around the middle word here, where different perspectives of what actually is a good system and a useful system come together, or actually kind of develop apart. And that's what I want to talk to you about. I mean, one funny term, I find funny term anyway, for artificial intelligence systems, people talk about ground truth. And I always wonder, what on earth could that be? I don't think that exists. But again, I mean, that's different rationalities, right? And we can discuss that whenever. I give you one kind of super classic example of where different rationalities hit. And this is an example that Daniel Kahneman and Amos Tversky have used a lot. And maybe some of you know Kahneman's book, Thinking Fast and Slow, where, among other things, he discusses this example and also different views one could have on that example. So I just ask you now, which is more probable, that Linda, a single 31-year-old woman with a philosophy degree and left-wing political views, is a bank teller, or a bank teller and an active feminist? First one? Yeah, okay. Second one? Okay. Engineers. Because obviously, right, simply by math, the second one cannot be more probable, right? I mean, we've learned that a single probability is always more probable than a combined probability, right? But the discussion here is, and that has been going on quite a bit among judgment and decision-making researchers in psychology and in economics also, that maybe we think more about not what is more probable, where then the formal mathematical answer would be a bank teller, but what we rather think about is what is more plausible. And to us, probably whatever stereotype we have about this person, Linda, and I mean, that's another amazing thing about psychology. I mean, we need so little information to have a full idea of Linda. I'm sure you could all tell stories about Linda simply based on that little snippet here, right? And from that little snippet, I guess you would think, no way she works at a bank. I mean, obviously, that's another stereotype of what are people like that work at banks. And we bring all of these stereotypes together, and then to us more plausible is that, well, bank teller is not very plausible, feminist sounds more plausible, so I guess we go to the second solution, right? And that's the kind of stuff then when you discuss among different people from different backgrounds, where maybe some people would say, well, if you don't get that clearly it's bank teller just by mathematics, I won't talk to you anymore, right? You're stupid. And on the other hand, you might have the person, well, I mean, with all the plausibility kind of considerations, I don't care about your math. In my real world experience, probably Linda is this more improbable thing of being a feminist and maybe also working at a bank for a while to get money for her next demonstration or whatever. When we go to technology, again, these different kind of worldviews have been discussed a lot. And one kind of opposition there that is discussed quite a bit is that on the one hand side, you have this what's been called the rationalistic perspective, where it's about scientific knowledge, objectivity, quantification, where the assumption is also that technology has pretty deterministic influences. I mean, this is also how technology developers sell their technology, right? They tell you, you will be better after you bought our stuff. So, I mean, that means there should be a one-to-one link between the technology you get and then whatever outcomes you have in the organization. And organizations usually are discuss kind of more, and hopefully I don't tread on anybody's feet here, a little bit of what I heard this morning from Ipsomed, where it was all about it has to be efficient, it has to be, I mean, the processes need to be whatever, failure-free, tuck. And we also heard that obviously some people kind of left. We didn't hear why. Maybe they had other views on how processes should go, whatever. I'm just saying that goes with this assumption about what is an organization. And in the extreme, even an organization is seen as a technical system, basically, where you have all the wheels that should fit together the best they can. I'm black and whiting here, or oranging and greening, obviously. And then something is interesting also, and I will come back to that in a moment. How is accountability defined? And we heard just a little bit about that a moment ago when we heard about reliability and safety, and that goes very quickly also to who's responsible for outcomes in an organization, for better or for worse. And usually this rationalistic perspective goes along with sort of an economic view on that everybody has instrumental motives, and I need to kind of match these instrumental motives, and then people are willing to take on accountability. On the other hand, the constructivist perspective is, I thought you'd like that, very much talks about subjective meaning about anything, really. So when new technology comes into organizations, and there's tons and tons of studies on that, where often sociologists or psychologists looked into what actually happens when people, for instance, I mean, ERP systems have been studied to death. I mean, even Excel has been studied to death. What happens when people all of a sudden can do Excel tables? And marvelous things happen to some people, and other people will never produce an Excel table in their lives. I'm one of those, sorry. So how does that happen? I mean, how do people take up technology or maybe actually not like it? How much do they maybe use it in ways that people actually didn't really think about? So this idea of there's kind of emergent nature of how people interact with technology. And with that, then also the organization is much more seen as a social system with sort of a psychologic rather than a technologic at work. And when you look at accountability, it becomes more difficult also because it's not so clear whose instrumental motive is at work where, but it's much more around people have different interests, there's goal conflicts, and you need to renegotiate these accountabilities all the time based on these different values. And what people have talked a lot about, and we heard about that this morning also, is if you want to develop and implement technology, probably you do need to take both of these views somehow together. And I give you one example where we tried that, and obviously this is not easy. I mean, it was a former co-worker of mine, Nadine Bienefeld, who's been working a lot in hospitals, and with this kind of move towards more artificial intelligence in various places in healthcare, she got interested in that, and she specifically worked on a project that's called ICU Cockpit, where artificial intelligence is to be used, or machine learning rather, is to be used to be better able to predict cerebral ischemia after neurological surgery, which is kind of more likely that it might develop with these kinds of patients. Obviously, when it does, it's horrible. So you want to be prepared for that or even prevent it. And here was the question, I mean, can we use existing historical data to help predict that more? And she brought sort of three different views together. On the one hand side, more generally, she actually did a Delphi study with data analysts, data scientists from all sorts of places of how likely did they even think artificial intelligence could actually help to automate or augment different functions in the ICU? And when she started this work, actually, that was when IBM Watson was still hot. So people were really, oof, wow, this will change the world of medicine. And actually, all doctors need to find new jobs like next year. But even those data scientists at that time, they thought, nah, some stuff, yes, other stuff, no. And it's the usual thing. The more kind of cognitive and routine it is, yes, technology can do it. The more social, emotional it is, no, probably technology cannot do it. We added a bit there on the right side here, where we were interested in what's actually the current work situation for people in these ICUs or more generally in these kind of acute care hospitals. And as you know, there is major shortages of people actually wanting to do this work. So we were interested, I mean, can we bring together what's kind of the job quality of people in these settings together with opportunities that AI might actually bring to actually make better jobs? And from those perspectives, then we also went into how do we make that technology then usable? I mean, doing the usual kind of user experience kind of things, co-design approaches, etc. So trying to have as complete a picture as possible, bringing in these very, very different perspectives. Obviously, not easy at all. Currently, that system is still only used by the physicians because they kind of went along with, yeah, I sort of understand, and yes, could be useful. To bring together the different logics from nurses and physicians has been difficult up to this moment. I'll give you another example from a project we did together with many, many colleagues at the ETH and to some extent at the EPFL, which is a National Center for Competence and Research on Digital Fabrication in Architecture, Engineering, and Construction. And we were interested there, and that comes to another of the words in my long title. We were interested in what's the design mindsets of these people developing new technology, for instance, using 3D printing, having robots build walls, using virtual reality to help masonry builders to do more crazy walls, etc. And we kind of looked at two components there. On the one hand side, lots of people have said, if you want to do especially the grand challenge stuff, it's all about interdisciplinary or even transdisciplinary research and collaboration. So we were just simply interested in what was people's pictures about where they themselves as professionals stand. And this is just 3 examples here with these little circles. So the gray one is always they themselves, and then they place the different disciplines they were confronted with in the NCCR to how close or far they are. So you have on the one hand side, for instance, here, computer science scientists who said, well, I'm a computer scientist, that's about it. Maybe I will do a little bit of mechanical engineering. And then you have somebody who is, who wants to be everything, really. I think all of what we do in this NCCR, that's all me. And then you have the last one here, me as a professional, closely civil engineering, a little bit of architecture, maybe computer scientist and optimization. And when we looked at what these people said about what motivated them to even be in this project and do the work they do, we asked, we just had lots of interviews, very open, and then we tried to group what they said. And this is what we came up with here. That on the one hand side, I mean, simply what's the focus of your own work? What are you interested in? And some people would say, well, I just want to do cool tech. And others said, no, no, no. I mean, this is about socio-technical stuff. I mean, I really want to think about what implications does my work have. And we thought this was interesting here because a lot of the people were actually designing technology for their own professions. So we thought the bridge then would be easier, that they would think more about what's actually the work design of the people I'm doing this technology for. But yeah, for some, but not definitely not for all of them. Then, I mean, would you even look at users? And some said yes, all the way. Others said no, not at all. And then this point again related to these bubbles, how important is it actually to work with other disciplines? And some would say, yes, I mean, for solving difficult technical problems, it's important to talk to the machine learning colleague next door who has maybe a different approach to machine learning, but that's about as interdisciplinary as it got for them. Or is it really, I mean, I want to really bring together major progress in the construction industry that we all know is far behind in productivity, et cetera, et cetera. And lastly, what's the overall envisioned impact? Is it technical? There's this cool stuff now out there in the world, or is it really that I want to have societal impact, which is very much linked to actually the overall vision of the NCCR, which is all about, for instance, concrete is bad, get rid of concrete, use less concrete. So there has definitely been always this layer of sustainability. So 2 examples of how we have looked at that. Moving to AI more specifically, I want to come to these 2 things, to these 2 concepts of control and accountability again. And question to you again, I mean, you have here 2 versions of presumably eventually maybe self-driving cars. Which one would you prefer? Who would like the left one? Okay. Anybody the right one? Okay. I assume, I guess we don't really have time to go through why you would pick one or the other. I could imagine that this has to do with this point of control and accountability. Do I want to sit in a car where I can do nothing? Where the control and the accountability presumably has completely been moved to the developers. They presumably did all the risk analysis, did all this stuff to in the end say the risk of me having whatever sort of accident or anybody else around me having any sort of accident is 10 to the minus whatever has been defined as the goal you want to reach. And I want these engineers to make that proof. And I wouldn't sit in a Tesla and I wouldn't use their self-driving autopilot thing because they obviously haven't really brought that proof. But once they do, then yes, I might sit in there, and I definitely then do not want a steering wheel and I don't want to touch anything. I want to read my newspaper and have a drink. On the left side, I guess it's maybe this kind of thing, it kind of feels funny to be on the road and not be able to do anything. Whether you can really do something still having that steering wheel there is a big question. I mean, there's tons and tons of research, and I know all of you, I guess, who are kind of in develop technology for jobs where people have to mostly supervise, monitor for hours. You all know that people are shit at that. And people don't like it, basically. It's boring. I mean, it's really hard to stay awake. I mean, very, very practically, no vigilance, whatever. And that's exactly that situation you're in that car. But it kind of feels like, well, if only yes, then I could. But whether you would do the right thing, probably not. And we have tons of accident analyses that show that people are not very good at then acting very last moment. So control and accountability is at the basis of a lot, I would say, of good design. And we've heard about agency and rules, and that kind of is the same sort of highway I'm traveling on here. If you give people control, that means they're enabled to do stuff. That's the agency we talked about, right? The accountability, on the other hand, motivates people, presumably, to use their control in the right way. So if you make people accountable for sort of a larger goal of what they're supposed to reach with their work, then they would use their agency for the larger purpose of the system. So you want these 2 things to go together. Often they're misaligned. I mean, you can have control with no accountability. I mean, that's the stories we hear. If we stay with self-driving cars, that's exactly what we hear from Tesla. It's like, we told you, we called it autopilot, but it's not. We're not accountable. And they fight with the safety board in the US over that endlessly. They're not willing to disclose the algorithms behind their autopilot, et cetera, et cetera. So you have that on the one hand, and then you have the other side of the coin, which is accountability without control. And that's, again, the situation drivers have had in all these analyses of Tesla accidents. And it's not just about Tesla. I mean, you have many, many of these examples in all sorts of industries. So overall, when you talk to socio-technical design, as we did this morning already, it's about bringing accountability and control together to help people to be autonomous, to use their control towards reaching system goals. A lot of that is about task interdependencies also, and it's about managing the routine, but also and especially the non-routine situations. Turning to AI now, the question is, does everything we know about socio-technical design, and we know a lot, and it's still hard, as we all know, but does it get even harder now, or does it even still work? And people have discussed, I guess, two main things that are different about AI. And one is that all of a sudden the developers also say, no, we are not in control either. We don't understand this stuff. It's magic. I mean, it's happening. And we try to kind of get a grip of it ourselves with all sorts of ways of making it explainable to ourselves, not to the users even. So if control isn't with the users anymore, but the developers also say, not with me either, then oops. And the other thing is AI changes through its own use, which makes this kind of, we develop something and then we give it to you, more difficult. Obviously, you can do that. And so for instance, in medicine, I think all the AI-based systems that currently are on the market, they have been frozen, right? They learned and whatever, but eventually you freeze it and say, okay, here you got it. And then the question is, when with new experience through use, when should these systems then be recertified, etc.? But it looks like there should be more collaboration between developers and users, much more than just looking at user interfaces, etc. It should really be about the basic kind of functionalities of these systems and the feedback loops needed for everybody to deal with these obviously only partial control for all actors now. And that's sort of what we've been starting to work on. How could that be? And explainability, that we heard a lot about already today, is obviously part of the story, but it's not the full story. And even with explainability itself, as everybody has mentioned already, you come back to these different rationalities. What is actually explainable, and explainable to whom? And we have kind of one tiny little glimpse currently into all of this in a more practical way through actually another maintenance project within the SBB, which is about visual inspection. And just having listened to the previous talk by Zurich, I mean, this is at the start. I don't know what your estimation is when this ever will be in use. It sounds like it will be a while, because for the moment it's just thinking about it. How could this work? Having, again, just image recognition and helping not only with this one piece of a train, but really with everything that could go wrong in a carriage. That could be brakes and wheels and whatever else. And I guess one thing that we started, and that to us was quite interesting, we felt, I mean, everybody has been saying it's not about socio-technical systems anymore, but with AI, it's about socio-technical landscapes, because you have so many more actors often. I mean, you have people that provide data, you have people that train data, you have people that test data, and that might be all sorts of different providers. And in this particular case, within the SBB, even you have different stakeholders, because there are so many different professions involved in actually creating good rolling stock and doing good maintenance. And we wanted one addition in there. We in the past have worked a little bit also with the regulator for the railways. And we thought it would be really interesting to get the regulator involved very early on. And sort of the people in the project kind of went along, and they're sure, talked to them. And we wanted to really invite them, for instance, into this upcoming experiment, which is a little bit this kind of explainability thing, What do you use for people to understand why the AI would recommend repairing or not repairing, or repairing with high priority or low priority? And we wanted the regulator to be there also. And the answer we got was, we can't, because then we lose our role as independent oversight body. And that is a bit of a trick. And I'm just curious also to hear from anyone really how others have dealt with that. Another thing we're really only just starting is to try to understand better, actually, many of you here, all the people that themselves develop technology. And I guess through my, as Olga pointed out, long history at ETH, and I really went to ETH because of these topics, because I felt technology is actually what drives work. So if I want to make good work, which work psychologists want, so that we all spend sensible 8 and 10 and whatever hours at work every day, I felt, well, I need to talk to engineers. And that hasn't been easy, and I keep trying. But for the longest time, and that's a little bit also this project with this NCCR, we looked at, well, why is it so difficult for technology developers to take on this other perspective, to change perspectives into this maybe constructivist mode that I talked about earlier? Why, I mean, are they stupid, or are they just don't want to, they don't care, they just want to do the cool stuff, or what is it, right? And more recently, I guess we've kind of started to think maybe this is a bit one-sided. I mean, maybe we really actually need to look much more into your working conditions. What allows you to actually do this stuff or not? And we heard recently, I guess, from OpenAI, where presumably some people left because they felt they wanted to do the good stuff and they weren't allowed to. I mean, that's the public version. The private version maybe is rather they wanted to do another cool startup, and that was a good kind of exit story. We don't know. But anyway, that has been talked about quite a bit. So we've started to interview people in all sorts of places. And I just give you 2 examples of what I heard in these interviews. There was one who he's a data scientist in a software development company that so far hasn't really done a whole lot in the realm of AI. They've only just started, and I just talked to him about it. I mean, yeah, how do you deal with this presumed black box kind of stuff? And he said, well, that kind of exists. I do find it difficult to really understand the systems that we are developing and using. And he also said, well, for exactly that reason, I wouldn't want to use AI-based systems for kind of high-risk type applications, for instance, in medicine. And then we discussed a little bit, well, what happened if then your organization had this new big, wonderful client and they wanted whatever AI stuff for medicine and healthcare, what would you do? And he just kind of said, probably would be all right. Probably we then wouldn't do it. I don't know. We can watch. And another conversation I had was with an HCI, human computer interaction researcher, at one of the big conferences on that topic, Kai, and where I was amazed to see half of what was presented there was all about prompt engineering. So I guess user experience is dead. It's about prompt engineering now. And this particular person, she started to, I mean, they looked at mostly using LLMs to help summarize text in the US. That's a big deal. That has been started to be used because, I mean, it's case-based law. That means you need to read tons of stuff. So to have somebody help you with that looks good. But then they found that, yes, these LLM-based summaries aren't so great often. So they, for instance, came up with something that to me was a bit funny, but maybe I just didn't quite understand it. But rather than just now providing summaries of all these texts, they would still give the user, whatever lawyer, judge, whatever, the full text, but they would be highlighted. And the reason for that was in my kind of cynical mind, that clearly then talking about control and accountability, that the accountability would stay with the user. I mean, if that judge didn't read then the other words that maybe were actually more important than the yellow ones, obviously it was the judge's fault and definitely not whoever produced these summaries in the first place, right? And I talked to her about that, and then she kind of said, I never thought about that. Okay, yeah, okay. I finish with, I think, a really, really interesting study where somebody looked at, again, kind of working conditions of tech developers, specifically AI developers, in a large range of companies with sort of a kind of snowball kind of sampling. So she got all sorts of people in there. And she came up with kind of a distinction that goes a little bit along this constructivist rationalist that I began with, what she called bright imaging versus dark imaging. And the bright imaging people, they would be kind of pleasantly surprised by whatever results their stuff came up with. And they felt it was a little bit kind of magic, difficult to understand, but that was kind of okay. And they would just delve deeper into the technology and learn more about it. And it's all about scientific discovery, doing cool stuff, and whatever moral elements that whole thing might have, depending on what applications they were working at, that to them was somebody else's worry. And they might kind of have safeguards like emergency buttons somewhere in the system. So like if it really goes wrong, you kind of just stop. And then she had what maybe not so luckily, no, she called dark imaging. I'm not sure whether that's a good selling proposition. But anyway, dark imaging, where people, yes, they also were confronted with surprises, but much more in terms of when they tried to do real world tests of their stuff. And where they were really pushed towards transparency, towards control. And they started to regain control. They started to embed constraints in their developments very deliberately. To say, I'm not going with the super duper, whatever, a million layers, a trillion parameter and deep neural network. I will do some simple stuff here. And the simple stuff maybe isn't that much worse than the super duper stuff. And it will definitely serve its purpose better because people will understand it. People will have control. I have control over it. And they felt very much kind of also morally obligated in terms of accountability that, yes, I mean, they should really deal with this. And I just leave you with that question for the barbecue and the rest of your lives. Which of these paths is actually more rational and which one is more meaningful for the people themselves as well as for anybody else? And I guess with that, then, which path would you want to strengthen, or maybe both, or maybe neither? Thank you very much.